Today we are going to look at the addition and subtraction of vectors. Let's start with the differences between the scalars and vectors. A scalar quantity is a quantity in physics that has only magnitude. For example, speed is 80 meters per second. No direction, it has only magnitude. Distance, only magnitude. Age, only magnitude. On the other hand, for the vectors, we have both magnitude and direction. For example, velocity, 12 meters per second toward west. Acceleration, 2 meters per second squared toward east. Force, 300 Newton toward south. So as you see, we specify the vectors with a magnitude and with a direction. Let's look at the properties of the vectors. If you want to draw a vector, just you are going to draw an arrow, and you can give a title to this vector. This is vector A, and we put an arrow at the top of this letter. So this is a vector. So the magnitude relates to the size of the arrow. The magnitude of this vector is the size of this arrow, and the direction relates to the way the arrow is drawn. It is drawn in this direction, so this is the direction of the vector. If this is a vector representing force, it means the force is applied in this direction, and its magnitude is the size of the arrow is the magnitude of the vector. Let's look at some other properties of vectors. If you have vector A, for example, and if you draw another vector, it is parallel to A and it's B, their magnitudes, their lengths are same and their directions are same, it means A is equal to B. These two vectors are equal to each other. On the other hand, what about A minus B? A minus vector means you are going to change only its direction. If this is vector A, and minus A is an opposite vector, same magnitude but direction is in the opposite direction. And you can, if you have a vector, for example this is vector C, you can carry this vector from here up to somewhere here without changing its direction. If it is parallel to the initial vector, you can move this vector from here to here without changing the magnitude and the direction. So these two vectors are going to be each other. Or if you move this vector from here to here, it will not change, it will be the same vector. Or you can move the vector in this direction. For example, you can move it somewhere here. You can move it to somewhere here. So this is again going to be the vector C. You didn't change the direction and you didn't change the magnitude, so you can move a vector in this direction, and also you can move it like this, perpendicular, so it does not change. One more thing, if you have a vector, if this is vector A, vector 2A is going to be the same direction, but the size is 2 times bigger. And A over 2 on the other hand, A over 2, this is A over 2, and it will be half of the size of A. Okay, let's continue with the addition of the vectors. When two vectors point the same direction, simply add them together. If you have vector A, for example, this is 20 units, it may be 20 meters per second, 20 newtons, 20 meter per second squared. And if you have another vector in the same direction, if they are both in the same direction, this is 15 units, and let's call this vector B. So if you are going to sum them up, just if they are in the same direction, A plus B, these two vectors will give us 20 plus 15, just we are going to sum them up, and it's going to be 25 units. Let's do an example related to this one. In this example, assume we have two vectors, example, and A plus B, we have two vectors. The maximum of A plus B is equal to, for example, 20 units, and subtraction of A and B, I mean you subtract B from A, I mean the minimum value of these two vectors is 6, for example, units and units. They may be newtons or meter per second and some other units. So what is A and B? What is the magnitude of A and B if the maximum value of two vectors is 20 units and the minimum is 6 units, and what will be the magnitude of each vectors? So if they are going to have maximum value when you add two vectors, their maximum value will be if they are in the same direction. It means A plus B, these are their magnitude, is equal to 20 units, and A minus B is equal to 6. So if we sum them up. Plus b minus b, they are going to cancel each other, and 2a is going to be equal to 26. From here, the magnitude of a is going to be equal to 13 units. And if we know the magnitude of a, we can find the magnitude of b, and a plus b is equal to 20. It means b is equal to 20 minus 13. This is 13, is equal to 7 units, sorry. Let's continue with the addition of vectors graphically. So assume you have several vectors. For example, this is vector a, and this is vector b, and this is vector c, and we want to add them graphically. The rule is place the tail of the second at the head of the first. This is the tail, and this is the head. So let me draw the vector a here. This is a, and I'm going to place the tail of b at the head of a. So I'm going to draw it like this. This is b, and now let's draw c. C is in this direction, so this is C. Now I will add a plus c plus, I need a plus b plus c. In this case, we add them graphically. Let's find the resultant vector. Let me change my color, and this is going to be the resultant vector from the tail of the first vector to the head of the last vector. This is R. Let's do a related example. For example, we are given several vectors. This is, for example, vector A, and this is vector B, and this is vector C, and this is vector D. Now, we are asked to find a plus b plus c plus d. These are all vectors. So as you see, this is a, this is b and c, and this is c. Graphically, they are added to each other. Now what is a plus b plus c? Let me change my color once more. Okay, it is not changing. There is some problem with the color changing. Okay, so what is a plus b plus c? As you see, forget about d, vector d, only a plus b plus c is going to be this one. So a plus b plus c, they all together equal to d. Why? Because this is d is given, it is already given. So a plus b plus c plus d, we have one more d here. The resultant vector will be equal to 2d. Let's learn the adding vectors by parallelogram method. Now assume we have vector a, this is vector a, and we have another vector, it is vector b, and we want to sum them up. In this case, I'm going to draw vector a, and I'm going to bring vector b, I'm going to bring the vector b somewhere here. Their tails are going to be at the same point. So now I'm going to construct a parallelogram for this. Here is, I'm going to draw a parallel line to the vector b, and I'm going to draw a parallel line to vector a. Then if I connect these 2 points, I can get the resultant vector r. So r is going to be equal to a plus b. These are 2 vectors, and this is vector a, and this is vector b. What about the magnitude of resultant vector? For this, we need to use the cosine rule. Cosine rule says that r squared, the magnitude of the resultant vector, is equal to a squared plus b squared plus 2ab cosine theta. Theta is the angle between a and b. Okay, let's continue with the if vectors are perpendicular to each other, then we are going to use Pythagorean theorem. If you have vector a and you have vector b, and you are going to sum them up, and there is 90 degrees between them. Let me draw from the beginning, sorry. This is vector a, and this is vector b, and there is 90 degrees between them. This is a, and this is b. In this case, again, we are going to use the parallelogram method. This is going to be our resultant vector r, and r squared is going to be equal to a squared plus b squared. That's it. So subtracting 2 vectors, when 2 vectors point the opposite direction, simply subtract them. For example, if you have one vector, this is vector a, and you have another vector, it is vector b, and it is in the opposite direction of a. Just you are going to draw a again and add b to the tail of the b will be the head of, you are going to add it to the head of the a. This is vector b, so the resultant vector is going to be this one. This is going to be our resultant vector r. For example, if a is equal to 30 units, b is equal to 15 units, then a minus b is going to be, r is going to be equal to 30 minus 15 is equal to 5 units. Okay. A negative of a vector is a vector of the same magnitude pointing in the opposite direction. So I told you, let me repeat it. This is vector a, and the negative of a is this, and it is pointing in the opposite direction with the same magnitude. This is negative a, and this is positive a. Let's continue with the components of a vector. This is vector a, and here are the components of vector a. To find the components of a vector, we are going to draw a perpendicular line from the head of the vector to the x-axis, and draw another perpendicular line from the top, from the head of a to the y-axis, and then this is going to be the ax component, and this is going to be the y component. The magnitude of ax is going to be equal to a times cosine theta, and the magnitude of y will be equal to a times sine theta. This is the way to find the components of a vector. How can we use the components of the vector to add the vectors? Assume this is vector a. It has two components. This is ax and this is ay, or you can draw ay somewhere here also. This is also ay, and ay is here. This is vector b. It also has two components. This is bx and this is by, or you can draw by to somewhere here. This is by, and this is ay. Now, how to add a plus b? A plus b. This is a and this is b. This is c. C is equal to a plus b. And we are now going to find c by adding the components of a and b. The components of the c, it is cx. This one. This is the component of c. Cx is equal to ax plus bx, because this is ax, and here is the bx. Here is the bx. Okay, when we sum them up, we are going to get cx. Similarly, what is cy? This is the y component of a. This is the y component of b, and when we sum them up, we are going to find cy. So this is the way to add the vectors by using the components. Let's solve an example related to this one. Now, let me first draw my x and y components. This is y and this is x component. I'm sorry, coordinates. This is y and this is x. Sorry, I have to draw from the beginning. This is the x axis and this is the y axis. As you see, something strange happens. Okay, let's solve an example. First, let me draw my x and y axis. This is x axis and here is the y axis. Forget about this one. This is y. And let me draw the vectors. The first vector is vector a, is making 37 degrees, and its magnitude is equal to 30 newtons. Assume these are vectors representing forces. And this is another vector. It is equal to b is equal to 20 newton. Please be careful that they are not, drawings are not in scale. This is 53 degrees. And we have vector c, it is downward on the y-axis. Vector c is equal to 10 newtons. To add these vectors, we need to find their components. Let's find ax, ay, bx, by, and cx, cy. Ax is equal to a times cosine 37 equals 30 times cosine 37 is approximately 0.8. It will be equal to 24 newtons. And ay equals a times sine 37. A times sine 37 equals 30 times the sine of 37 is 0.6 approximately, So this is going to be equal to 18 newtons. And let's look at bx. Bx is equal to b times cosine. Here is the angle is 53 degrees, cosine 53 degrees. It will be 20 times cosine 53 is approximately 0.6, 12 newtons. And by, sorry, it is b times sine 53. And it is 20 times sine 53, 0.8 approximately. It will be 16 newtons. And cx, c does not have any components in the x direction, it is 0, and cy, it is already given 10 newtons. So now let's draw all these vectors, these components on our axis again. Now, ax is 24 newton. Let me change the color. Okay, ax 24 newtons. Bx is in the opposite direction, and ay is in this direction, ay, and there is a by also in the same direction, and there is cy in this direction, and this is 24, and bx is 12, and ay is equal to 18, this is 18, by is equal to 16, it is 16. Now these vectors are in the same direction. I'm going to draw one more axis like this. So 16 plus 18, it is going to be equal to, let me draw something like this. I mean, this is 10, and 10 minus 16 will be, these are opposite to each other, it will be 6, so 6 plus 8 is going to be equal to 18, is going to be equal to 24 newtons upward. The sum of these three vectors, 2 up, 1 down, is 24, and these are opposite to each other. It is going to be equal to 12 newtons toward this side. So since they are perpendicular to each other, I'm going to use Pythagorean theorem, and r will be equal to 24 square plus 12 square root. And in doing this calculation, we are going to get approximately 26.8 newtons. That's it. Thank you for listening. See you next time.